Welcome back. In the next set of videos, I will be taking you through the common set points and most of the configuration options that are available in the VCCX2. For the vast majority of units, there are many defaults that don't need to be adjusted, and there's also quite a few less used set points which we will not discuss. What I want to focus on is the set points and configurations that you'll need to use day in and day out for about 95% of the units you're going to work on. I can go over every single item and every single little nuanced set point, but you're just going to get bogged down with too much stuff, and these videos are going to be very, very long and at that point tedious. So I'm deciding to cut it down to probably about half of the set points and pretty much all the configurations. That way you'll be razor focused and you'll learn all the important stuff you need, and the rest of the little things that you might need someday in the future you can figure out then. Please keep in mind some of the features that we'll be discussing do span multiple screens, so I'll do my best, and for the most part we'll always stay on the same screen, but there might be one or two times when I'll be jumping over to a different screen to continue a configuration. So to access the set points area, either through this button here, and then you do open set points, or from this screen you do the exact same thing. So it doesn't really matter which way you go, but those are your two options. So this here is the set point screen for the VCCX2. Now I'll skip through them real quick, and so you see set points and temperatures essentially in here. You have the set points that basically go with the static and air category for fan speed, suction pressure, static pressure, things like that. Then you have delays and staging. You have miscellaneous stuff, which there is a lot of stuff in here, and it really is a miscellaneous one. There's a lot of really good information in here, and then there's some that you're probably never going to use or use very infrequently. There's calibration. So over here you can see that I've thrown in a negative 40-degree calibration on my outside air sensor so that it looks a little different when we're on the details viewer than all of the other thermistors that I have, because right now they're all sitting side by side. It didn't really give you a good sense of what is different and what is not. So I wanted to just show that one a little bit. And then the space sensor offset is also shoved up a little bit as well. So from here, there's the outputs, which these are all the configurable outputs that we can potentially put into any VCCX2. It's also very similar to what you can do in the VCBX, VCMX, and VCM, but the VCM looks a little bit different than this. So this is configuration 1. Again, I'm not going to go into any real detail on these right now. I just want to kind of show them all to you guys. This is configuration 2, and this is configuration 3 here. So you have the RSM V as in VFD over here, and then you have the RSMD as in digital scroll over here. And then you have the expansion module. It's kind of also a bit of a miscellaneous page, but for the expansion modules. So with that out of the way, let's go back to the temperature settings that we have in our unit. While the screen might look a little bit daunting, we're just going to go over the key points that you need to set some of the primary functions of the unit. So for instance, the mode enabled set points are what determine if the unit is going into heating mode or cooling mode. Essentially they're similar to your household thermostat, but with a few differences. To enable cooling, your control temperature sensor must be higher than the cooling mode enabled set point plus the deadband, which is shown down here. So how you'd read that is 1 plus 74 is 75, so anything above that, such as 75.1, would enable cooling. Now this could potentially be your first stage economizer, or it could be compressors, it could be chilled water, It can be pretty much whatever, however you have it set right now in your system. To enable heating, it's the same concept, except you remove the deadband. So 71 degrees minus a 1 degree deadband would be 70 degrees. So anything less than 70 degrees, such as 69.9, would enable heating mode. It's worth mentioning that you always want to keep a separation between these. You don't want to do, let's say, 71 and 72 and then have a 1 degree deadband. It's going to cause your unit to kind of freak out a little bit and to essentially shut off very, very quickly and flip between modes when it really shouldn't be. So I like in Fahrenheit, if we're talking in Fahrenheit, I like about a 3 degree differential. Sometimes I'm in Canada, so we certainly need our heat. I often set it to 71.5 as the mode of operation for heating. Sorry, the mode enable for heating. And then I usually set the mode selection deadband to 0.6. For cooling, if you want it a little bit tighter, set it to 74. If you want it a little bit looser, set it to 75 or whatever you want after that. So before we go further, I'd like to classify what a control temperature is and what the mode enable temperature is. If you were speaking about your house, it would be the thermostat on the wall. It's a sensor which controls whether the unit is in heating mode or cooling mode. Space sensors and AAON units are the most common form of control sensor, but you could take a makeup air unit, for example, and then that would be requiring an outside air sensor because the space sensor or supply sensor or whatnot just simply wouldn't be able to change temperature and figure out exactly what's going on with the temperature fast enough. So you need something that's outside in the airstream, ready to change it to heating, cooling, or vent mode at the drop of a hat. So for instance, if you're doing a traditional VAV, you'd set it to the supply sensor. If you're doing a makeup air unit, you'd set it to the outside air sensor. If you're doing a constant volume unit, you could be setting it to the space or the return sensor. So this mode enable here is all based on whatever mode enable sensor you have selected in your unit. Now that is further away in the configuration 2 screen, but that's where that comes from. So we just learned how to enable heating or cooling. Now we need to figure out how much to heat or cool. That's where this here for cooling and this here for heating come into play. AAON will deliver cool or hot air based on the supply air temperature. The temperature sensor is typically installed 10 to 15 feet down the duct or before the first branch to ensure proper mixing of air before it reaches the sensor. The basic form of cooling and heating set points is the heating SAT set point or the cooling SAT set point. So this is the cooling one, this is the heating one. These two set of set points will determine when it's in that mode, what you want the leaving air temperature to be, and it will stage compressors or heaters, chill water valves or hot water valves or whatnot, up and down as required to meet the specific leaving air temperature set point that you're putting into this section here. So as a note, you'll find in these videos that I use the term leaving air temperature or supply air temperature pretty much interchangeably. So it doesn't matter which one I say, it essentially means the air that is leaving the unit in the supply duct and traveling down the duct to eventually reach the space. So just setting the leaving air set points for cooling and heating is the most basic and frankly most common ways to have leaving air control. You could, if you wanted to, you could add in resets. So what a reset does is it basically says, so we'll look at cooling here and say, if in this case we'll talk about it as if it was a constant volume unit with a space sensor. So if the space was really hot, it was for some reason 80 degrees, we want to deliver very cold 50 degree air into the space. But if it was more manageable, 70 degrees, or whatever set point you want to set to, let's say 65 or whatever, then you can have a leaving air set point of 60. Same idea here. If the space is quite hot, well, we really don't want to deliver a lot of heat, so we're going to just give you 80 degrees. But if the space is a little on the cooler side, well, maybe we want to give you 90 degrees. The key is that these are dynamic ranges. So if it was 75 in the space, you'd be delivering 85-degree air, which is quite nice. And vice versa with this up here. So just keep that in the back of your mind. It adds a little complexity, and not really for anything other than it adds complexity to potentially troubleshoot later on, or for people, and I should say technicians, who might not know everything about these units, and they think that all they have to do is change a certain set point, when in fact that one set point is being dynamically adjusted every single second or two and whatnot. So just keep in mind that if the space needs a reset and it needs to be very, very finely tuned control, such as lab applications or things like that, then that's great, and it has a functionality to do that, and it works very, very well. On the other hand, if it is let's say building pressurization, you might need it, you might not need it, but just make sure that if you do start putting in some of the more fancy and robust settings in here, it's able to be actually managed by the technicians who are running the facility. So that's on how to enable heating and cooling mode, and then how to deliver the proper temperature air over here and over here, or over here and over here, to the space. So there's a couple other modes that we haven't discussed, which one of them is ventilation mode, and one of them is dehumidification mode. So for instance, ventilation mode happens when, let's say you were in heating mode and you heated up the space to kind of 73. Well, now it's in between these two, and it's crossed over the threshold where, okay, so now I am very comfortable, the space is satisfied, I don't want to heat anymore, I can't cool either, so essentially all it does is it shuts off the heater, shuts off the cooling, and just delivers untempered air into the space. Now, if you have 50% outside air, it's going to probably get pretty cold very quickly. But if you have a more common 10 or 20% fresh air, especially if you have a heat wheel, you might not actually have to heat for quite a long time. So it just depends on the style of unit you have. And that's why every single technician who does a really good job, or AAON rep, who does a really good job with tweaking and tuning a system, who takes pride in it, will start using decimal places. They will start really figuring out what the temperature is in the space, what's common for this space, how much fresh air you're putting into the system, and then we'll make sure to put all these set points in accurately, and not just put in kind of a default option here. Like, I would never just throw 74 and 71 and 80 degrees. Usually I would do 85 to 88 degrees in here anyways, but it's always nice if you spend a couple of hours after the unit's been starting up to actually see what is happening in the space. So for vent mode, that's already been discussed. It's the space between here after it's crossed over the deadband threshold. So the deadband happens at the bottom and the top of here, but it also happens in the middle. So basically after it rises up the deadband above here, so let's say if it hits 72 or 73, it will shut off and go into vent mode. For dehumidification mode, that depends on two different things based on whether you're in constant volume mode or whether you're in makeup air mode. So if you're in makeup air mode, you'd be using these makeup air dew point calculations down here. So all you do is you adjust those down here, and we'll be talking about that in a later video. And then if you are using the space sensor, you're going to be down here, I believe in miscellaneous, you're going to be using the indoor humidity set points. So basically dehumidify down to 52, then stop, start dehumidifying at 58%. Things like that. The default is actually 50% and 60%, but I like a little bit tighter control, typically speaking, so that's why I usually adjust those a little bit. So that was the end of video 1, which we covered, as you can tell, a very small portion of this screen. There's going to be 1 or 2 more videos on this screen here, and we'll be going into a bit more detail. Keep in mind, there's a lot of information, and frankly, what this video here is very, very critical that you understand the mode enables and the leaving air temperature set points. So if you feel that you need to, please rewatch the video before moving on. Thank you very much. Have a great day, and I'll see you in the next video.